Hello class, this is Mr. Arnott. I'm going to try using videos to record some of the solutions that we post. Maybe as you see how I go through it in steps, it'll maybe be a little more clear how to do problems. I'll still scan them, post them, but let's give this video thing a try. It seems to be pretty popular now, and I think it makes a lot of sense. So this is equation set, problem set 2, where we're incorporating acceleration with this displacement. First problem, number 56. Car traveling at 40 kilometers per hour. So this is an initial velocity. We're given that. It then accelerates at 2.3 meters per second. So we're given the acceleration. We're given the time period that it's accelerating. So we have a delta t. And then how far has it traveled in that time? So how far has it been displaced? So it looks like we're looking for a change in displacement. And what is the final velocity? It looks like we're also looking for V2. So we're given V1, we're given A, we're given delta t, and we're asked to solve for delta d, and then we're also asked to solve for V2. So it's kind of like we've got two problems here. This is problem number 1, and this is problem number 2. So before we look at the equations, alarm bells should be going off here that we've kind of got a mix of units. We've got kilometers and hours, and here we got meters and seconds, and here we have seconds. So we kind of have to decide what world we're going to live in. And kind of the default setting is always work in meters per second, or meters and seconds. So what we want to do is convert the initial velocity. We want to get rid of the kilometers and the hours. We want to get it to meters per second. So we'll just restate it here, that V1 is equal to 40 kilometers per hour. That doesn't change, that value. But I need to put a couple of conversion factors in here. And my ultimate goal is I want to get it into units of meters divided by seconds. So let's convert the time first. I want to get rid of hours. Hours currently is in the denominator. I still want to have seconds in the numerator. So I need seconds in the denominator, but I need hours in the numerator so I can cancel them out. Well, 1 hour is this equivalent to 3,600 seconds. So the hours will cancel out, and I'll have a conversion. Next, I want to get rid of the kilometers. So I need to get the kilometers in the denominator. I want to have meters in the numerator. So conversion of meters divided by kilometers would be 1,000 meters is the same as 1 kilometer. So now the kilometers cancel out, the hours cancel out, and I'm left with the units I was looking for, meters divided by seconds, meters divided by seconds. Now it's just a question of doing this math. You're going to do 40 times 1,000 divided by 3,600. So let's get out the calculator. 40 times 1,000 divided by 3,600 is 11.11 meters per second. So the initial velocity is 11.11 in terms of meters per second. So now let's look at the equations we're going to look for. We've got a V1, maybe I'll do that in red. We've got an A, we've got a delta t, and we're looking for a delta d. So I'm going to flip to another screen. It's kind of cool software. My son was showing me this. So over here, just a reminder, we have a V1, an A, a delta t, and a delta d is what we're looking for. So it's almost easier to ask, well, what don't I have? Well, right now I don't know what the final velocity is. I do know an acceleration. I know an initial velocity. I know a time duration, and I'm looking for a displacement. So of the 5 possible variables, the only one I'm really not looking for right now is the final velocity. So find the one that doesn't have that, and that's this equation here. So from the big 5, it's equation number 3. So I'll write that out. Delta d is equal to the initial velocity times the time duration plus 1/2 the acceleration times the time duration squared. So now I'll go back to hopefully screen 1. Let's see if this works. Yay, it worked. So delta d, V initial 11.11 meters per second times the delta t is 2.7 seconds plus 1/2 times acceleration is 2.3 meters per second squared times the time duration squared, so 2.7 seconds squared. So 11.11 times 2.7. I still have the 11.11 in my calculator, so I'll just buy 2.7. And that's basically 30 meters. Now, how do I know it's meters? Because I have meters per seconds times seconds, so the seconds cancel out, which is good. Kind of shows I did it in the right order, because I'm left with the desired unit of meters, which is a unit of displacement. Now let's check the second expression. 0.5 times 2.3 times 2.7 squared. And that comes out to be 8.38 meters. How do I know it's meters? Well, let's double check. I have meters in the numerator, that's a good. Seconds squared in the denominator times seconds squared in the numerator, so the seconds squared cancel each other out, so I'm left with units of meters. So that's good. So my delta D total is 38.38 meters. So maybe we'll call it 38.4 meters. Therefore, cars distance traveled was 38.4 meters. Second question, we have to find V2. So let's go back to the second screen. This time I do want to have V2 included in my list of variables. Let's see. I calculated the delta D, but let's assume that this wasn't a two-part question, and question one, first part didn't ask me for delta D. I want to show you how, if all we were looking for was the final velocity, that this would then be the formula we'd use, because we have an initial velocity, v1, we have a delta t, 2.7 seconds, and we have an acceleration, 2.3 meters per second squared. So we will use equation 1. From the big 5, equation number 1, v final equals v initial plus a delta t. So v2 equals v1 plus a delta t. So v1 is, that was just a conversion, v1 was a given, plus the acceleration. The acceleration is 2.3 meters per second squared times 2.7 seconds. So v2 equals 11.1 meters per second plus 2.3 times 2.7, 6.21 meters per second. How do I know it's meters per second? Meters in the numerator? Yep, meters in the numerator. Divided by seconds squared times seconds. So one of those cancel out with that. It leaves me with seconds in the bottom. So that's good. And I get a V2 equal to 17.32 meters per second. Therefore, after acceleration, car's final velocity was 17.3, we'll round it down, meters per second.